Well, yeah, it's like everything else. And when you look at, what's going on with the permafrost, and by the way, I'm going to have a video coming out within a couple of weeks of new research that's been done in the lap tip sea, but more towards the continental, the shelf break, where the shelf goes steeper and becomes a slope going down to the deeper portions of the Arctic Ocean. They were doing studies there, and they're finding that the warming, because the water's coming in warmer, that they're causing splits in the rock, and these rocks contain trapped methane.
Oh
This
my
is this is not the biogenic source, like from when the permafrost thaws and you have microbial action, degrading the vegetative material and slowly releasing methane, but still, because of the expanse of the area, is a lot of it. This is basically causing the rocks to split, and then you have major gushes of methane, basically like
wow.
methane farts, basically. And this we're seeing increased measurements of this. All of a sudden, over the lab tip, see, look at the methane levels. Hey, because it's coming out of the ground. So you have that going on. You have the ocean heat energy. You got, the lag effects of CO2 and what it does to temperature. So we're still yet to feel the effects of current levels of CO2, not for another 10, 15 years. You put
Right.
these all together, and the IPCC is saying, well, we can limit the temperature increase to 2 degrees C or less by 2050. What are you smoking?
Yeah, I
We're
know.
despite what they're saying, it's 1 point. No, we're past 1.5. We really are, and we have the equivalent of pushing, you know, on a conservative guess, we're pushing 600 ppm CO2 equivalents in the atmosphere. It's probably more like 650, maybe even pushing 700 if you look at some of the upper end estimates. But let's say go with the low end conservative 600. It's certainly a lot higher than 417, which is the official amount given now, but it's actually more like 421 if you just look at CO2 specifically. When you look at methane and nitrous oxide, those levels, then it's about pushing 600 ppms. So you look at all that, and then you look at the fact that the Arctic and the Amazon are now carbon sources, no longer carbon sinks, and you look at, you the fact that trees themselves are so stressed out that many of them are no longer photosynthesizing. That means they're not drawing down the CO2. They're respiring, which means they're drawing down oxygen. So when you take these into account, those models that say 5 to 7 C by 2100 are the more reliable, the more believable estimates.
Wow, this is,
Sorry to say. And an increase of 4 seeds enough to cause human extinction.
and I don't know, I don't get where people think like we're just gonna merrily go along. It's there's gotta
Remember, go along until, as what was in Buck Rogers, when the silence crashed, the ground came up and met us. Yeah,
yeah, I know. It's coming faster than ever, right? That's how it seems.
yeah.
It's just we're in like this lag effect of like a human lifespan versus like the acceleration of like the climate in such a short amount of time. And I know we're like in this weird period where it's like it's happening, but like I don't know. We're getting when the further we get to 2100, right? This magical year, like obviously the worse it's gonna get based off of math. These numbers and stuff. There's evidence.
And the thing is, the effects are going to continue well after. I mean, you're still going to have the ice melting. You're still going to have the sea level rise. Even if, humans go extinct, we've locked into you can't argue with physics, and we've locked the physics in. To be blunt,
Interesting.
the physics has been locked in. And so these things are going to continue. Now, if humans are extinct and no longer burning fossil fuels, of course, there'll be a slowdown, but we still locked in the increase. So the exponentiation may not increase as much, but it still will increase because you're still going to have the permafrost thawing. You still got the warmer conditions leading to the positive feedback loops. So you're still going to have all that going on. You're still going to have the mass extinction event continuing along even after humans are extinct. You're still going to be killing off the mammals and the birds and the fish and the et cetera, and the plants, so you might be left with a bunch of microbes and then, new life forms will emerge.
I know. Damn it. I know. And I mean, this is the cycle of like life and death. It's just, we have these mass extinction events. They've been documented, and, the earth, leaves behind this information. And I feel like it's just wild that we're like in the middle of one.
We are.
It's just
I mean,
wild, but
well, we are in the middle of an extinction event. And everyone keeps putting, when we're going to have the BOE, blah, blah, blah. It's like,
oh
well,
yeah, that magical term. Yeah.
we just have a lot of open water right now. That's not good to begin with. Let's just look at that. And then there's the other problem is that what is a BOE? How is it defined? Among some oceanographers, they define BOE as having less than 1 million square kilometers of ice in the Arctic Ocean. So if you've got 900 square kilometers of ice, okay, you still have ice, but that would, to some oceanographers, that's a BOE. Others basically say zero ice anywhere in the Arctic Ocean. So it all depends how you define it. So we need a standard, let's come up with a standard definition of BOE and go from there. But that still misses the point, because the point is we're losing multi-year sea ice, we're losing sea ice, the extent, the volume, and so on. So now you have all this open water that's absorbing heat. Not to mention the influx from the Atlantic and the Pacific, bringing in warmer water. I just put out that video yesterday. Arctic sea ice succumbs to Atlantification.
Yeah, I'm all caught up. Yeah, you did a good job. I mean, there's a lot going on. The electrification issue.
Really, this is just continuation of a lot of the videos I've done before. Sea ice melt explained the Barents Sea becoming Atlantified, et cetera, et cetera. It's just, this is the latest data telling us how much worse it is, or how much further along this process has taken. So so people, they're getting focused on the BOE, which will happen. When? Who knows? But it will happen. But the point is, even if it's not happening, the fact is we're having more and more open water. And that's what we need to be focusing on. And that's what's not good.
Wow, I mean, there's such complex issues, and man, it's just alarming. I know it's like the rapid change of environments, I guess. And just, you said, like the methane issue, the alentification issue. Jim, it's severe.
October, of course, is, when you look at the average temperatures in Alaska, October is the most anomalous because it's so much warmer than typical when you compare to the other months of the year. This October is no different. There's a couple morning I got down to 10 degrees. This morning it was 20 degrees, but daytime temperatures reaching like near freezing, upper 20s, lower 30s. Because the Arctic Ocean is open right now. There's some ice forming in the Chukchi and the Beaufort, but there's still a lot of open water. We're just getting all that latent heat energy out of the water, warming the atmosphere.
I feel like one of your videos talked about this, is like summers will be longer.
Yeah.
Yeah,
Well,
like
basically the extent of how the open water season will extend.
so interesting.
And the data is indicating that from first of all, the ice is freezing up later in the year. It's melting earlier in the year. To freeze up is because you're trying to get rid of all that latent heat energy from absorbing the summertime sun rays. So it has to cool down, and then it has to cool down past 0 C because of freezing point depression, because salt water salt in it. So, so you have to, freeze it down colder to freeze it. But then you have warm water coming in from the Atlantic, from the Pacific, and that heat is diffusing underneath and melting the ice earlier. So the ice is melting earlier, it's freezing later. So the extent of being open waters is increasing. Well, if you increase the extent of open waters, you increase the heat absorption of the water, you increase in the heat content. That heat eventually is going to diffuse out to the atmosphere, keep things warmer, etc., etc. So yeah, you're going to see an extended open water season in the Arctic Ocean. I'm working on a couple of videos. It's going to be a two-parter called Ocean Tipping Points.
Okay, that sounds good.
So it's going to be a two-parter because like I started blabbering away, and it's just like, oh my god, this is like 2 hours long.
Okay.
You gotta do some massive editing, but yeah, it's like,
Then you gotta upload it and all that. Oh, I know, Jim. It's
oh
like
yeah,